Right, so what we can do is we can write each of these numbers as a product of their prime numbers, right? As a product of their primes. I'm going to tell you guys something, the coolest thing I've heard today. One of the other maths teachers at my school says whenever we write a number as a product of its prime, they call it a pop. Pop, because pop stands for product of primes. So what we're going to do is we're going to learn the word pop, which is kind of nice, don't you think? So whenever we need to take a number and write it as a product of its primes, we're going to say pop. So I want you guys to put pop in the chat for me when I ask for that. And how we write a number as a product of its primes, or how we pop the number, is we put it into our calculator. We go 24 equals shift, and then we look for the button that says fact, and that will pop that number for me. So I want anybody who's got a scientific calculator next to you, please pop 24 for me. Let's pop 24. Oh, Omi, thank you. Lovely. All right, so Omi says that when 24 is popped, it gives us 2 to the power of 3 times 3. Well done. But remember, 24 was already to the power of x plus 1. So we're going to write 2 to the power of 3. I'm just going to put a 1 here. All of that to the power of x plus 1. Multiplied by, somebody pop 18 for me, please. Pop 18. Thank you, Khulani. It's going to give us 2 times 3 squared. I'm going to put a 1 over there. And all of that is to the power of 2x minus 3. Somebody please pop 36. Pop 36 for me. Thank you. Oh, Khulani, you're very fast at this. You and Abu. Wow. All right. If we pop 36, we're going to get 2 squared times 3 squared. And all of that is to the power of x. Multiplied by, somebody pop 54 for me, please. Well done, Khulani. Excellent. It's going to give us 2 times 3 cubed. I'm going to put a 1 next to that 2. All of that is to the power of x minus 2. Somebody pop 4, please. Thank you, Abu. Thank you, Khulani. If we pop 4, we're going to get 2 squared. All of that to the power of x. All right, that's step number 1, which we're already off. We're off to a great start, guys. What we're going to do next is we're going to get rid of the brackets. Let's take away the brackets. How do we take away the brackets? Wherever we see a bracket and an exponent, we're going to multiply in. Good. We're going to distribute. Bracket and exponent, distribute. Bracket and exponent, distribute. Bracket and exponent, distribute. Bracket and exponent, distribute. All right. So remember, guys, each one of those needs to be multiplied with whatever's on the outside. So we now need to take 3 and multiply it by x plus 1. So it's almost like we're distributing. It's like we're writing 3 times x plus 1. Now I'm writing 3, x plus 1. So we need to distribute, guys. So we're going to get 2 to the power of 3x plus 3. Right. Multiplied by 3 to the power of, that's 1 times all of that. That's just going to give us 3 to the power of x plus 1. Times, now let's go to this next one over here. That's 2 to the power of 1. Now, if I take 1 and multiply it with 2x minus 3, that's going to give me 2 to the power of 2x minus 3. Multiplied by 3 to the power of, now if I do this one, 2 times 2x and 2 times negative 3, 2 times 2x will give me 4x. And 2 times negative 3 will give me negative 6. All right, let's keep going, guys. We're done with the top. Let's go to the bottom. Over, we're going to do the same thing at the bottom. We're going to distribute that. All right, so we're then going to get 2 to the power of 2 times x will give me 2x times 3 to the power of 2 times x, 2x, multiplied by 2 to the power of, now I've got 1 times x minus 2. That's just going to give me 2 to the power of x minus 2, multiplied by 3 to the power of, I now need to distribute that 3 to each of them. That will give me 3 to the power of 3x minus 6 multiplied by the very last one. Let's distribute 2 times x, 2 to the power of 2x. All right. Okay, let's keep going, peeps. At the top, I'm going to note that I've got 2 like bases being multiplied. So when I have like bases being multiplied, who wants a lollipop? Who remembers? What must we do before we add like terms? Yay! Abu! Lollipop for Abu today. Yes. Lollipop for Abu. Abu remembered to keep the base. And he did. He dreamt about it. This one belongs to Abu. Well done, Abu. Abu remembered to keep the base. Beautiful. Keep the base. So we're going to keep the base of 2. And we're going to add our exponents. We're going to add like terms. So we'll have 3x plus 3 plus 2x minus 3. Yes, virtually eat it. Yes, sir. 3x plus 2x will give me 5x. And then 3 plus negative 3, those two will cancel. So we won't have that at all on the top, right? Then we're going to get multiplied by, I've got another base that looks the same. There, like bases being multiplied. So I must what? I must keep the base of 3 and add my exponents. So I'm going to add x plus 1 plus x minus 6. Let's add like terms, guys. Hulani. I'm so chuffed, guys. I've never been so excited in my life for people to say, keep the base. Here's a lollipop for Hulani. Well done, my darling. Beautiful work. Excellent. Good. We're going to keep the base and add exponents. Well done. So we're going to get x plus 4x will give us 5x. And then 1 minus 6 will give us negative 5. Well done, Abu. That's it. Good. Now we're going to do the exact same thing at the bottom. We're going to do the exact same thing at the bottom. I've got 2, 2, and 2. Like bases being multiplied, I'm going to keep my base of 2. And we're going to add the exponents. So I've got 2x plus x minus 2 plus 2x. Let's add like bases, peeps. 2x plus x, that's 3x. Plus 2x is 5x. So I'm going to get 5x. And then there's a negative 2 over there, sneaky one that's going to go minus 2 times. My other like base is 3 and 3. Like bases being multiplied, I'm going to keep my base. Keep the base of 3, and we're going to add our exponents. 2x plus 3x minus 6. 2x plus 3x will give us 5x, and then the minus 6 must come with us. All right. Now, I've got like bases being divided. I have like bases being divided. So I'm going to keep my base, and instead of adding my exponents, I'm going to subtract. Who remembers how do we subtract, guys? How do we subtract? Who remembers? Minus. Yes! Abu, another sweet for you. I feel like I'm gonna give you cavities, my guy. I'm absolutely gonna give you cavities because you're just doing the best things today. Good. Well done, Fulufelo. And a sweet for Fulufelo as well. I love it. Sugar rush all the way around. Oh, just excellent things. Love it, guys. Wonderful. This one is for Abu. And this one is for Fulufelo. Beautifully done, my darling. Well done. Good. So we're going to go from the top. We're going to go 5x minus, and we're going to put the thing at the bottom in brackets, minus 5x minus 2 multiplied by 3 to the power of 5x minus 5 minus, and then put that thing in brackets as well, 5x minus 6. All right. Then we're going to distribute that negative on the outside. Distribute it in. Distribute. Okay. And then we're going to get 2 to the power of 5x minus 5x plus 2 multiplied by 3 to the power of 5x minus 5 minus 5x plus 6. I hope you guys realize where those pluses come from. A negative and a negative is going to give me a positive 2, same as over here. A negative and a negative 6 will give me a positive 6. So we need to just make sure we are keeping up with that. All right. All right, so let's tidy this up. We're going to get 2 to the power of 5x minus 5x will give us 0. So I've got 2 to the power of 2 left. Good, oh me. Beautiful. Times 3 to the power of 5x minus 5x will also cancel. And now I've got negative 5 plus 6. That will give me 3 to the power of 1. Good. And all I've got is numbers left. So I can just find the answer to the numbers. 2 squared is 4 times 3 is 12. So my final answer is 12. Ta-da! Ooh, that was a lot of work. That was a lot of work. But we got there. We made it, guys. We made it. I'm so glad we did. All right. All right. That being said, yes, you are supposed to write 12. Remember, Abu, the instruction says simplify. Okay. Only in this case, we don't have to because there are no negative exponents. Okay, so if one of our exponents was negative, then we'd have to turn it into a fraction so we can flip it. Okay, but in this case, there are no negative exponents. There's no need for us to turn it into a fraction. All right. Alternatively, if you're not sure whether it needs to be turned into a fraction or not, punch those numbers into a calculator and get the answer. Okay. Excellent. Good work. All right. Okay, let's jump into today's lesson. It is not lesson 1, it's lesson 2 of 2. All right. Oh, Amina, sorry, should I go back? Let me go back. Sorry, my darling. Don't we add exponents? Not in this case, not when we get over here. All right, not when we get over here, my darling, because I don't have the same base. This is a base of 2, and this is a base of 3. So we can't actually add exponents there. In this case, we just need to evaluate each number separately. We just did this. This is all we did. We just said 2 squared is equal to 4 times 3 to the power of 1 is just 3. And 4 times 3 would give us 12. That's all we did. No worries. I see Tyler's just joined us. Welcome. All right. You're very welcome, my darling. Good question. Buchet, trigonometry is coming up soon. I just need to finish equations and inequalities, and then I think we've got trigonometry coming up soon, but I'll check for you. All right, I'll check for you and I'll let you know when we get started on trigonometry. Okay, it's definitely going to be term 2, my darling. It's not going to be term 1. I can tell you that. Guys, let me tell you something. Let me tell you something. I don't brag about many things. I don't brag about many things, but I'm gonna riz myself up, guys. I am the queen of teaching trig. I am the queen of trigonometry. So I need you guys to stick with me, and I promise you, you're gonna eat, guys. By the time we're done with trig, you guys are gonna be on some we ate and we left no crumbs because I'm that good, guys. I am that good. I'm that good. Trust me. Stick with me, guys. Stick with me. I promise. We're going to do it. Don't even stress trig. It's going to be so lovely. We're going to love it. Yes. It's not going to be a battle, Narisha. It's going to be like your best friend. Don't even stress. All right. Let's get into today's lesson, guys. Okay. Let's go back to algebraic fractions for a second. Let's go back to algebraic fractions for a second. I'm going to give you guys this sum. I'm going to say I've got 2x squared minus 4x over 2x. And I want you guys to simplify for me. What would we do over here? How would we simplify that? Yes, Khulani. Khulani remembered our default setting. All right, Narisha, in this case, we don't need to pop because there's no exponents. but we're going to get back to the exponents in just a little bit. All right. It's all good, my darling. I'm just explaining something. All right. I'm just explaining something. Okay. We're going to do HCF. What is my highest common factor at the top there? Good, Abu. Excellent. It's 2x. So we're going to take 2x out. And if I take 2x out, I'm going to get x minus 2 left over 2x. Right. And then now that I have 2x at the top and I have 2x at the bottom, I can cancel, right? Cancel, cancel. So I'm going to cancel that one and that one. And my final answer is going to be x minus 2. Now, remind me, guys, when we look at this over here, why did we have to factorize? What sign told us that we have to factorize? The what? Yes, oh me, beautiful. The negative, good. The minus or the plus will tell us that we need to factorize. Right. Excellent work. Now, let's go down to this question. Here's the next one. Let's look at question A over here. Now, I know that this is exponents, guys. I do. I know that it's exponents, but I know that, like the one we did above, I can't just cancel, cancel. Why can I not do this? Why can't I just do that? Why not? Because there's a what? Yes, Theo. Beautiful, Abu. Because there's a minus in between. There's a minus in between. Right. So what we're going to do, guys, is we're going to learn how to split and factorize. We're going to split and factorize. I'm going to explain the split part very quickly. Right. Let's talk about splitting. If I say to you guys that I have 3, let me not use 3 because that's part. Yes, that's it. Hulani, beautiful. If I give you guys 5 to the power of x plus 2. Oh, let me do it the other way around. Sorry. Yes, good. So I must get 5 to the power of x multiplied by 5 to the power of 2. How would I add these? I know that my like bases are being multiplied. So I'm going to keep my base and I'm going to add my exponents. So I'm going to end up with 5 to the power of x plus 2. Give me a thumbs up. Are we all in agreement? Yes? Are we good with what ma'am has done here? We're all good. 5 to the power of x times 5 to the power of 2, 5 to the power of x plus 2. Now, what we want to do in this particular question is we want to do this exact step, but in the opposite direction. We want to do it in the opposite direction. So what I'm going to do is I'm going to give you 5 to the power of x plus 2, and I want you to tell me that 5 to the power of x plus 2 is 5 to the power of x times 5 to the power of 2. Okay, even though it is the same basis, why don't we multiply? We do. Okay. Yes, we do. But remember, when we have the same base, it's like if we had, I'm just going to make another example, guys. If I had x squared times x to the power of 3, what's my final answer? What's my answer there? X to the power of 5, right? What we did was we left the base exactly the same and we added exponents. Now, this rule doesn't change when the 5 is in the base. Okay, good, yes. So when I have 2 to the power of x times 2 to the power of 3, my base must not change. My base must stay exactly the same. My base must stay as 2, and then I must add my exponents. Now, unfortunately, x and 3 are not the same exponent, so I must go x plus 3. All right. Now, I want to give you 2 to the power of x plus 3, and I want you to split it for me. So we're going to split that as 2 to the power of x times 2 to the power of 3. So we're doing this step, but we're doing it in reverse. We're doing it in reverse. All right. Okay. Let's get to the question. We're going to go to this question over here, and we're going to split. We're going to split this. All right. So I've got 3 to the power of x plus 1. Does anybody want to unmute for me and split this for me? Anyone? Narisha. Hi, my darling.
Hi, ma'am.
Hi, my darling. Do you want to split here for me?
Yes, ma'am.
Go for it.
So it will be split into 3 to the power of x times 3 to the power of 1.
Excellent. I want you to continue. Don't go anywhere. All right. And then do you agree? I'm still going to get minus 2 times 3 to the power of x
Yes.
over 3 to the power of x times 2. Are we okay with that?
Yes.
Yes? Okay,
Yes.
good. That was the split part. Now, if we factorize, Narisha, do you remember what is our default setting when we
Highest common
factorize?
factor.
A lollipop for you. A beautiful lollipop for Narisha, everybody. Well done, my darling. Okay, so if we look at the top over here, we have a common factor. Remember, this is one term and that is one term. Do they have anything in common?
3 to the power of x.
Absolutely. So we're going to take 3 to the power of x out as a common factor. You okay with that?
Yes.
Okay, good. So if I take 3 to the power of x out as a common factor, what do I have left? Remember, I've taken it out and I've taken it out.
3 to the power of 1.
Good.
Minus 2 times 1.
Good.
Oh.
2 times 1. You can just say 2, right? Because
Okay.
2 times 1 is just going to give us 2. Is that okay?
Yes.
Excellent. Over 3 to the power of x times 2. Now, Narisha, do I see anything on the top and on the bottom that I can cancel?
Yes.
What do we see?
3 to the power of x.
Beautiful. So I can cancel and I can cancel. And now we've only got numbers left. Yes, I've got 3 minus 2 over 2. You see that?
Yes.
Beautiful. What is 3 minus 2 over 2?
1. It will equal a half.
A half. Good. I'm going to get 1 on the top, 1 over 2. My darling, you deserve all the flowers. All of them. All the flowers, all the cakes, everything. Mwah, 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 mwah. Beautiful. Very well done. Amazing work, my darling. Okay, so I don't want us to get lost. Okay, I don't want us to get lost. I want to make sure that everybody's with me. So I'm going to show you guys another way to do this exact question that's actually going to help us out. All right, we're still going to split. We're still going to split. But before we factorize, what we're going to do, in between the factorize over here, before we factorize, we're going to add in a case substitution. We're going to add in a case sub. Okay. I'm going to show you how this is going to work. Now, Narisha has done this so beautifully for us. She split beautifully for us. She's done all the work. I'm just going to erase this part for me, from you. Okay, so I'm going to then do this. I'm going to say, let k equal the thing with the x. I'm going to say, let k equal 3 to the power of x. So that means wherever I see a 3 to the power of x, what am I going to replace it with? With k, right? I'm going to replace it with k. So there, I see a 3 to the power of x there, so I'm going to put a k. K times 3 minus 2 times, there's another 3 to the power of x, so I'm going to replace that with k. Over, at the bottom, I see another 3 to the power of x, so I'm going to replace it with k. So I'm going to get k times 2. Let's clean this up a little bit, guys. K times 3 will give me what? K times 3 gives me 3k minus, that was that part there, minus 2 times k will give me 2k over, at the bottom, k times 2 will give me 2k. Now, do we see it? Is it a little bit easier for us to factorize? Yes? What kind of factorization do we have on the top? It's actually k sub, right? It's case substitution. Or we don't even, I mean, not case substitution, factorization, but we don't even have to factorize, guys. We don't have to factorize. What is 3k minus 2k? What is 3k minus 2k? Just k, just k. So I actually have k over 2k. And now the k's are just going to cancel, cancel, cancel. I've got 1 left on the top, so my final answer is a half. All right, tell me in the chat, guys, the first method or the second method, which one is easier for you? The k sub or the normal substitution? Omi says both. Okay, some people say second. I see a lot of people saying second. Nico says first. Okay, I'm going to be honest. Personally, I prefer K sub because when the questions get a little bit more challenging, then K sub really, really helps, guys. It really does help. Can I give you guys another question? Yes? Let's do another one. I want us to do another one. All right, here's the next one. 3 to the power of x plus 1 multiplied by 2 times 3 to the power of x plus 2. Okay, I will explain in just a little bit, Amina. All right, over 7 times 3 to the power of x. All right, I know, oh, sorry, I'm missing a sign. There's a plus here. There's a plus here in the middle. Okay. All right, I know that I can't just cancel top and bottom. Why can I not just cancel top and bottom, guys? Why not? Good, yes, Omi, because of the plus. All right, yes, there's a plus sign in the middle. So I know that I need to split and factorize. So I want you guys to all split and factorize. And then those of you who want to use K sub, go ahead and use K sub. Those of you who know how to do it without it, go ahead and do it. All right, Amina, my darling, do you want to unmute? Are you okay to unmute, my darling? I want us to speak about that question that came before.
Hi, ma'am.
Hi, my darling. I don't want to leave you behind. Okay, I'm going to give everybody 2 seconds to quickly write this question down. I think everybody must have by now. I want us to do that. All right. Can you and I go back to that first question that we had? Yes?
Yes.
Okay, cool. Okay, let's look at this question from here. Are you okay with the idea that we split? Is splitting okay for you? Yes?
Yes.
Okay, good. So I want you to note that I have 2 terms. Do you agree with me that I have 2 terms at the top here?
Yes. Because of the minus.
Okay, why do I say I have 2 terms?
Because of the minus.
Yes, because of the minus. Good. Terms are split by a plus or a minus. So I've got 1 term and I've got another term. Okay. What do these 2 have in common? What common factor do they have that I can take out?
3 to the power of x.
Good. They both have 3 to the power of x. Now, if I take 3 to the power of x out, what do I have left over here? I've just taken out 3 to the power of x. What do I have left?
3 to the power of 1 minus 2.
1 minus 2. You see how it's not actually, the things that we actually have here are not in the exponent. It's just numbers. Okay, because 3 to the power of 1 is just the same as 3. Okay, and then at the bottom, I've got 3 to the power of x times 2. Now, do you see how the 3 to the power of x and the 3 to the power of x just cancel, right?
Yes.
So do you see how the rest of the operation I'm doing is just basic math? It's just 3 minus 2 and the top over 2.
Yes.
Is it making sense now? Are we okay with it?
Yes, ma'am. But from here, how do you get 1 over 2? Because you can't simplify because of the minus, can you not?
No, we can. It's just numbers, my darling. What's 3 minus 2?
1.
1 over
Oh.
2. That's all.
Oh, okay.
Okay, we just do the top and then we put it over the bottom. Is that okay?
Yes. Okay.
All right.
Thank you.
Are you still with me?
Yes, I am.
Excellent. Shall we try this one with everyone else?
Yes.
Okay, good stuff, my darling. Well done. Good question. Keep the questions coming if you're not sure. Well done, Fulani. All right, peeps, shall we chat? All right, beautiful. And now I've gone way off the screen. All right. Okay, let's talk about this one over here. All right, I know that I first have to split, right? Let's split. If I split, I'm going to get 3 to the power of x times 3 to the power of 1 plus 2 times 3 to the power of x times 3 to the power of 2 this time and not 1 over 7 times 3 to the power of x. Okay, now I like k sub, so I'm going to use k substitution. If you didn't use k substitution, wait until the end and see if your answer looks like mine. All right. Okay, so I'm going to say let k equal 3 to the power of x. So I see a 3 to the power of x, I'm going to replace it with k. So I'm going to get k times 3 to the power of 1 plus 2 times, there's the 3 to the power of x, so k times 3 to the power of 2 over, at the bottom, I'm going to get 7 times, there's another 3 to the power of x, so I'm going to replace that with k. This is equal to, now I'm going to simplify the top already before we even go there. I'm going to get k times 3, because 3 to the power of 1 is just the same as 3. K times 3 is 3k. Plus, now I've got numbers over here. I've got 2 times 3 squared. 3 squared is equal to 9 times 2 will give me 18. 18 times k will give me 18k over 7k, which is equal to 3k plus 18k will give me 21k over 7k. Now I know that my k's will cancel, cancel, and 21 over 7 is just equal to 3. All right. Princess is saying, ma'am, why are you multiplying the 2 times the 3 squared? Okay, remember when we split it over here, Princess, when we split it, we already had 2 times 3 to the power of x plus 2. So when I split this, all of them are multiplied to each other. So I've got 2 times 3 to the x times 3 squared. So all 3 of these things are being multiplied to each other. So I can actually take the 2 and multiply it with the 3 squared. Are you okay with that idea, Princess? Excellent. Good question. All right, good. But if you did it the other way, if you factorized out a 3 to the power of x, that's perfect. That's perfectly fine. it kind of goes away. They cancel each other out. So somebody's asking what happened to the exponent. Remember, k is actually the same as 3 to the power of x. So what we actually ended up with at the top was 21 to the power of times 3 to the power of x over 7 times 3 to the power of x. So 3 to the power of x divided by 3 to the power of x is the same as cancel, cancel. We can cancel those two. They're equal to 1. Okay, let me do the other method because I don't want to leave people behind here. Okay. No, Fulufelo, not in all expressions. You'll see soon that it's not going to be that way. All right, let's see what happens if we don't use k. Let's see what happens if we don't use k. All right, are we all in agreement? I've got two terms, and I can take out a highest common factor of 3 to the power of x. Give me a thumbs up or a yes, ma'am, in the chat if we all agree that I can take out a common factor of 3 to the power of x. Yes? Are we cool? Good. So at the top, I'm going to take out a common factor of 3 to the power of x. Now, if I take 3 to the power of x out over here, I'm going to end up with 3 to the power of 1 plus, now there's a 2 there, 2 times that 3 squared over there, 3 to the power of 2, over 7 times 3 to the power of x. Now, do I see anything on the top and on the bottom that's the same that I can cancel? Yes. Good, Theo. I can cancel the 3 to the power of x and the 3 to the power of x. Look at that. It still disappeared. It's still gone, right? So I then have 3 to the power of 1 plus 2 times 3 to the power of 2 over 7. And now if I'm afraid I'm going to make a mistake with the answer there, pick up a calculator and punch that into a calculator exactly the way you see it. Remember that dot means times. So make sure you're not putting comma 3 squared in your calculator. You're putting dot or a multiply sign in your calculator times 3 squared, and that's going to give us 3. If you put that into your calculator, the answer that's going to come out is 3. I'm going to ask one more time. Give me a thumbs up if you understand the methods that ma'am has used. Give me a thumbs down if you're still confused, because I want to make sure that we're all together. Beautiful, sharp. All right, can I step it up a notch? Let's step it up a notch, peeps. Okay. Here's your next sum. 4 to the power of x minus 9 over 2 to the power of x plus 3. Whoa, now I've got a problem, okay? I've got a problem in that over here, I've got a 2 to the power of x, but over here, I've got a 4 to the power of x. But I know that I can do something to 4. Narisha, this is your moment. What can I do? Instead of split, I can, that new word that we learned at the beginning of the lesson, I can what? Who remembers? I can, yay, princess! Dinelle also remembered, Armina also remembered, beautiful. I can pop 4. I can pop 4. Yes, I can pop 4. And 4 is then going to change into 2 squared. Good. So I'm going to get brackets 2 squared to the power of x minus 9 over 2 to the power of x plus 3. Right. Now I've got a bracket and an exponent. I'm just going to multiply those two. So I'm going to end up with 2 to the power of 2x minus 9 over 2 to the power of x plus 3. Now, what I want us to do, guys, is I want us to split 2 to the power of 2x. How can I split 2 to the power of 2x, guys? Who's got an idea for me? Okay, I knew somebody would say that. Now, Abu says I can split it as 2 to the power of 2 times 2 to the power of x. Do we agree? Yes or no? Who agrees? Princess says yes. Princess agrees. Anybody else agree? Who says yes? Who says no? Fulufelo agrees. Tristan says no. Buche says yes. Nonka says no. Princess says no. Princess now says no. Now everybody's like, Theo's like, no. Okay. And here's the problem that we're going to have. Let's put this back together. Like bases being multiplied, what am I going to get? I'm going to get 2 to the power of, I'm not going to get 2x anymore. I'm going to get 2 to the power of 2 plus x. And that's not the same thing. It's not the same thing as 2x. Right. So how would we have to actually split it? Narisha, tell me. How would we split 2 to x?
You would put 2 to the power of x in brackets and then put it to the power of 2.
Oh, but that's the same thing that we've had over here. And that's not going to help me really. It's not going to help me really. Okay. So can I show you what I want us to do? Are you okay with me showing you what I want us to do?
Yes.
Okay, that's fine, my darling. I love you for trying. I want everybody to try all the time. That's it, Abu. Good. I want it to be 2 to the power of x times 2 to the power of x. Okay, because when we put it back together, like bases being multiplied, I'm going to get 2 to the power of what? What is x plus x, guys? 2x. All right. So we can't split it as 2 and then 2 to the power of x. We need to split it as we're adding them together, x plus x. All right, are you guys with me here? We all good? Okay, so let's split. If I split over here, I'm going to end up with 2 to the power of x times 2 to the power of x minus 9 over 2 to the power of x plus 3. Okay, we've split. That was the split part. How do we then factorize this thing now? Ma'am, this thing of yours, it's not factorizing. Help us. Help us. Won't we pop the 9? I mean, we can. Yes, Theo is going to give us 3 squared. It's not really going to make a difference. Now, this is why Teacher Coco prefers K substitution. Let me show you why Teacher Coco prefers K substitution. Let's do this, guys. Let's say let K equal 2 to the power of x. Let's go ahead and do that, guys. Now, what I'm going to get over here, I see a 2 to the power of x that's going to give me k times another 2 to the power of x will give me k minus 9 over, I've got 2 to the power of x at the bottom, that's going to give me k plus 3. Okay, guys, what's k times k? K times k will give me what? K squared. Good. So at the top, I've now got k squared minus 9 over k plus 3. Now, do we see what kind of factorization should happen at the top? What kind of factorization do we need at the top? Dots. Aha, princess. Now we see dots. Good. So I know that I can open 2 brackets for dots. Good. That's it, Nonka. I'm going to get k minus 3, k plus 3, all over k plus 3. Now, do I see anything top and bottom that can cancel? Yes, I do. Good. So I can see k plus 3 and k plus 3 cancels. And my final answer is going to have k in it. My final answer will have k in it. So I'm going to have k minus 3. But do you guys remember what k actually is equal to? What is k actually equal to? K was actually equal to 2 to the power of x. Right. So my final answer is actually 2 to the power of x minus 3. Mwah, mwah, mwah. Thank you, Abu. I ate I left no crumbs. Beautiful. All right. How did we feel about that, guys? Can I give you an example to try on your own? Can I give you an example? Yeah, let's do it, guys. Let's do it. Here's your example. Theo, it's fine. If you don't do the K method, it still works, but I prefer the K method because it's easier to see. And you'll see when I give you another example just now that it must be a lot easier for us to see before we even go there. All right, here's the next one, guys. 25 to the power of x minus 49 over 5 to the power of x minus 7. All right. Give me a thumbs up if you know what to do. Give me a thumbs down if you want me to go through this question with you. Yes, Narisha. Beautiful. Well done. Narisha remembered a lollipop for Narisha, guys. Ah, beautiful. I'm loving it. This one belongs to Narisha. Well done. We're going to pop 25. Go ahead and pop 25, guys. And then we're going to put all of that to the power of x. And then remember to let k. I'm going to give you guys 2 minutes. Good, Abu. Give me an answer. Give me a final answer, my dear. Don't give me step by step. I want you to go all the way to the final answer and tell me what we get. Good. Well done, Kulani. Well done, Theo. Yes, Tristan, but your answer can't have K in it. K was not the original question. The original question did not have K in it, so you can't leave your answer with K in it. Well done, Abu. All right, let's have a chat. That's it, Tristan. Well done. Good stuff, guys. Okay, let's go ahead and pop 25. We know that 25 is going to become 5 squared. It's okay, princess. Here we go. All right, so I'm going to get, in brackets, 5 squared to the power of that x that's already there, minus 49, over 5 to the power of x minus 7. Right, then I see a bracket and an exponent, so I'm going to multiply these two together. I'm going to get 5 to the power of 2x minus 49 over 5 to the power of x minus 7. Now, I know I have to split 5 to the power of 2x. Remember, don't split it as 5 to the 2 and 5 to the x. Each of them need to get their own x. So I'm going to get 5 to the x times 5 to the x minus 49 over 5 to the x minus 7. And then from here, I'm going to let k. Let k equal 5 to the power of x. That's going to give me a 5 to the x, that's k, times 5 to the x, that's k, minus 49, over 5 to the x, that's k, minus 7. Now, k times k will give me k squared, minus 49, and that's perfectly fine if you don't split them, Tinyiko, as long as you end up with the correct answer, k minus 7. All right, that on the top is dots, beautifully said, Abu. So I know that my answer must go into 2 brackets. I'm going to get k minus 7 and k plus 7 over k minus 7. And now I know I can cancel. That one and that one will cancel. So what I have left is actually k plus 7. And I know that my answer didn't actually have k. My k was actually 5 to the power of x plus 7. Did I not tell you guys to stick with me? I got you. I got you. Look at that. Ah. Beautiful, Narisha. I want to give you one more example before we run out of time. Can I give you guys one more example? Yes. All right. Here's your other example, guys. Let me see. I need to see if I can find it now, because it's quite a tough one, and I want us to be able to do it. All right, let me see if I can find it. Where is it? Where is it? Where is it? Ah, here it is. All right. All right, 9 to the power of x plus 3 to the power of x minus 2 over 9 to the power of x minus 4. I can hear everybody already on some, ma'am, angeke, ma'am, what are you trying to do? What are you trying to do? Yeah? Okay. Narisha's already there. Theo's already there. They already remember to pop. Guys, lollipops all around. Lollipops. Yay, lollipops for everybody who remembered to pop 9. All right, we're going to pop the 9s. We're going to pop this 9 and we're going to pop that 9. Yes, Hulani saw it, 100%. It's a trinomial, guys. It's going to turn into a trinomial. But let's see how we get there. Let's go ahead and do it. All right, so I know that 9 is going to pop into 3 squared to the power of x plus 3x minus 2 over 9 is also going to pop to 3 squared to the power of x minus 4. I know that I've got a bracket and an exponent, multiply in. Bracket and exponent, multiply in. Good. So we're going to end up with 3 to the power of 2x plus 3 to the power of x minus 2 over 3 to the power of 2x minus 4. All right. Let's split that one and that one. If we split them both, I'm going to get 3 to the power of x times 3 to the power of x. And Narisha, you are far ahead of me. 3 to the power of x minus 2 over 3 to the power of x times 3 to the power of x minus 4. Let k, excellent guys, let k equal 3 to the power of x. So on the top, I'm going to get k times k times k plus k minus 2 over k times, at the bottom, k times k minus 4. If I put this together, it's going to give me, k times k will give me k squared plus k minus 2 over, at the bottom, k times k will give me k squared minus 4. I notice on the top, I've got a trinomial. What do I see at the bottom? What do I see at the bottom? Dots. That's it, Theo. Beautiful. It's dots. So let's go ahead and factorize. Let's factorize the top. It's a trinomial, so I'm going to open 2 brackets. 2 brackets at the bottom. Okay. At the top, I'm going to get k and k. I need factors of 2, 1 times 2, that are going to give me positive 1k. That's going to be k plus 2, k minus 1. At the bottom, that's a difference of 2 squares, so I'm going to get k plus 2 and k minus 2. Do I see anything at the top and at the bottom that can cancel? Good. The k plus 2s can cancel. Excellent. Right. So we're going to get that one and that one will cancel. So my final answer is going to be k minus 1 over k minus 2. But I know that my original answer did not have k in it. So I need to go back and replace k with 3 to the power of x. Good. So my final answer will read 3 to the power of x minus 1 over 3 to the power of x minus 2. How was that? It's kind of nice when you know what you're doing, hey?